Streamlining Kubernetes Deployments, a step-by-step guide to Amazon EKS with Terraform. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Understanding Amazon EKS Amazon Elastic Kubernetes Service. EKS is a managed Kubernetes service that simplifies deploying, managing, and scaling containerized applications using Kubernetes. As organizations increasingly adopt Kubernetes for its orchestration capabilities, Amazon EKS offers a secure and resilient platform to run Kubernetes without needing to manage the control plane infrastructure. With EKS, you can leverage the power of Kubernetes while AWS handles the heavy lifting of managing availability, scaling, and patching of the control plane. Overview of Amazon Elastic Kubernetes Service and its benefits. Amazon EKS offers several benefits that make it a preferred choice for deploying Kubernetes clusters. Managed Control Plane. AWS manages the Kubernetes control plane, ensuring high availability and scalability. Security. Integrated with AWS Identity and Access Management, IAM, VPC, and AWS Private Link, EKS provides robust protection for your workloads. Scalability. EKS integrates with AWS Autoscaling, allowing dynamic scaling of your Kubernetes nodes. Compatibility. EKS is fully compatible with standard Kubernetes, enabling seamless integration with existing Kubernetes tools and applications. Importance of Terraform in infrastructure management. Infrastructure as Code, IAC, has revolutionized how we manage cloud resources. Terraform, an open-source IAC tool, is widely used for provisioning, managing, and automating cloud infrastructure. It allows you to define your infrastructure in code, making it easier to version, share, and replicate. Using Terraform for EKS deployments, you can automate and standardize your cluster creation, reduce errors, and enhance team collaboration. Why choose Terraform for managing EKS deployments? Terraform offers several advantages for managing EKS deployments. Automation. Terraform automates the entire deployment process, from VPC creation to EKS cluster setup. Modularity. With Terraform, you can create reusable modules for your infrastructure, reducing duplication and improving maintainability. Declarative syntax. Terraform's declarative syntax makes it easy to define your desired state and ensures consistency across environments. Version control. Terraform managed infrastructure can be versioned, allowing you to track changes and roll back if necessary. Setting up the network stack. Before deploying an EKS cluster, setting up the network stack is essential. This includes creating a virtual private cloud, VPC, public subnets, and an internet gateway to allow external communication. Creating a VPC, public subnets, and internet gateway configuration. VPC creation. A VPC isolates your EKS cluster and nodes within a secure, private network. Define the VPC's CIDR block and create subnets to distribute resources across availability zones. Public subnets. Public subnets are necessary for external access. These subnets will host the nodes that require internet connectivity. Internet gateway. An internet gateway enables communication between your VPC and the internet, allowing your EKS nodes to pull container images and interact with external services. IAM roles for EKS cluster and node A group. IAM roles are critical for controlling access to AWS resources. When deploying an EKS cluster, you must create specific IAM roles with the necessary permissions for the cluster and node groups. Establishing necessary permissions for cluster and node operations. EKS cluster role. This role allows the EKS control plane to manage AWS resources on your behalf. Attach policies like Amazon X cluster policy to this role. Node group role permits nodes to interact with AWS services such as EC2, S3, and CloudWatch. Attach policies like Amazon X worker node policy and Amazon X2 container registry read-only. Deploying the EKS cluster and node group. With the network and IAM roles in place, you can deploy the EKS cluster and node group using Terraform. Terraform scripts for cluster and node group creation. Cluster creation. Define a Terraform script that creates the EKS cluster, specifying the VPC, subnets, and IAM roles. Use Terraform's AWS_X_cluster resource to create the cluster. Node group creation. Define another Terraform script to create the node group, specifying the desired instance types, scaling configuration, and IAM role. Use Terraform's AWS_X_node_group resource for this purpose. Implementing variables for modularity. Implement variables in your Terraform scripts to enhance code reusability and maintainability. Variables allow you to parameterize your infrastructure configuration, making deploying multiple environments with different settings easy. Enhancing code reusability and maintenance. Modular code. Break down your Terraform code into reusable modules for the VPC, IAM roles, EKS cluster, and node groups. This approach makes your code more organized and easier to manage. Version control. Store your Terraform modules in a version-controlled repository, enabling collaboration and tracking changes over time. Conclusion. The future of Kubernetes deployment on AWS. Terraform's flexibility and automation capabilities make it an excellent choice for managing Amazon EKS deployments. Terraform can streamline your Kubernetes deployment process, reduce manual errors, and ensure consistent infrastructure across environments. As Kubernetes continues to evolve, Terraform will remain a critical tool for managing infrastructure on AWS, enabling organizations to scale and quickly adapt to changing requirements. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.